We're studying for the big test coming on Wednesday on quadratics, and here is a parabola. If it touches like this, that means if it touches the x-axis, like right there, it's only got one solution. It's also called a double root, because when you factor it out, you'll end up with two of those numbers. So that's a -3. You'd end up with a solution of -3 and -3. You have two of them. Why is that? Because you always have two solutions for these things, even if it's the same number twice. Normally, though it's touching twice like this, the solutions would be what? 3 and 5. Okay. Or it could be up here and then touching nowhere. It's not touching the x-axis at all. Well, that means that there still has imaginary roots. And those can only be found with the quadratic formula. That's one of the things that's really good for. All right. Of course, it could be underneath and like rotated too. So like it could be a parabola that looks like this, or it could be down here where it doesn't have any real roots. All right. Now, you've done a lot of other stuff. You've done completing the square. You've worked with simplifying big radical expressions, they're called, which are things like this that you get when you use the quadratic formula. Remember how to simplify those? Okay. You've done complex numbers, some hard completing the square problems. So we're going to practice all that stuff today. But first, let's grade your homework. So let's pause here and grade your homework. So here are 4 problems. I don't expect you to be able to do them all without any help. You probably could, but I want to work through these with you. This first one, number 1, the common mistake people will make is think, oh, it looks like one of those multiply it out kind of problems. But it's not. Why? Because it's got a plus between the two parentheses. Yes. So it is an add problem. So let's go ahead and add like terms. Now you might think, well, these i's are confusing me. Just treat them like a normal variable, like if it's an x. Just add the things you can add, simplify it, and give me an answer. Give it a shot. Mr. N, what'd you get? You want to multiply, don't you? You can't multiply because it's a plus. So what are they? Well, you get 5i, good. Okay. Plus 3. That's it. 5i plus 3. That's all there is to it. Raise your hand if you had it right. Okay, good. On to the next one. This one is a multiply. And yes, it's pretty much just treat I like it's a normal variable and multiply it all out. But there's one little catch at the end. Typically only a couple kids notice. So multiply it out. There's one little trick to it. I'll pause while you do that one. So what you get, 6i squared plus 8i plus 2. Who caught the trick to this? Sam. I squared is -1. You are correct. How many of you remembered that? All right. It's more than an average class. Okay. So let's talk about that for a second. 6i squared plus 8i plus 2. 6i squared plus 8i plus 2. I squared is -1. Why? Well, I squared, wouldn't you agree that I squared is the same as I times I? Okay. And what is I? Square root of -1. And the square root of -1. So that's the same as that, right? Okay. Well, here's one of those little definition things. Like, what do you get when you put these two together? Well, what if I had the square root of 9 and the square root of 9, and I multiplied them? What would that give me? Square root of 81, which is 9. You see how it's the number that's underneath the root? Take a guess. If I did the square root of 7.2 times the square root of 7.2, what do you think the answer is? 7.2. See what the pattern is there? So then that means that the square root of -1 times the square root of -1 gives you what? -1. So wherever you have an I squared, you can put a -1. So then if you stick that -1 right here, all of a sudden you have 6 times -1 is -6. And then the -6 can be added to the 2. And then you have what? -4. So the final answer would be 8i minus 4. Who had that before I had that? Okay, good. If all you forgot was that I squared is -1, then just try to keep from making that mistake, because if you left it this way, I would have to take off half a point for not having simplified it all the way. And half credit is harsh, really. All right, let's go back to this page, because there's another kind of problem here I want to do, number 3. This one I've actually got all worked out for you just to save us some time, and then I'm going to have you do one like it in a minute. Notice how this 5 doesn't change a bit the whole way through the problem. See what I'm saying? The problem is all about this 90 here, and that can be simplified down. We can break down square root of 90 and square root of 9 and square root of 10, and I also threw in the square root of -1 because that takes care of my negative here. Then, when I have the square root of 9, it turns out to be 3. And so it's, and then the 2 times 3 can be multiplied together, and I get the 6. So now it's 5 minus 6 and the square root of 10. And notice that I just slips back in front of the square root. You don't write the I at the end. You write it up by the 6. Okay? Now I've got one like that for you to try. Right there. Give that one a shot. I'll pause while you work on that. Okay, so I broke it up this way with 3 square roots. The first one I'm going to use is 36 and 2, because 36 times 2 makes 72. And then I'm going to use -1 here. That takes care of my negative. Then I have 6 plus 4 times, and what's the square root of 36? 6 times square root of 2 times I. That's what I transferred in for that -1. And now I just have to like rearrange some things. 6 plus, what's 6 times 4? 24. 24, and then the I comes up here, and then the square root of 2 is there. I think I'm done. Raise your hand if you got the same thing. Good. Okay. Let's move on. Oh, there's one more kind. That x squared plus 9. You're solving that one. You got to look for, I could just set this equal to 0. Why? Because the x-intercepts are where y is equal to 0. And f of x is like the y, so we put a 0 there. And all of a sudden you can just solve it like normal and say, whoa, subtract 9 from both sides. You have x squared equals -9. What do you do now? Square root. And I got square root, and I got x equals square root of -9. Ooh, that's a little weird. Well, square root of 9 would be 3. But then the negative makes it 3i. Get that? And yes, because this is an absolute value, because we did a square root of a variable, now I have x equals plus or minus 3i. I bet a lot of you forgot that plus or minus before. All right. Now, another place where this comes up is in factoring. You can factor this if you want to. Do you remember difference of squares? They're kind of like this. They were like x squared minus 9. And then you break that up into 2 parts, x plus 3, x minus 3. Raise your hand if you remember that. Okay, good. This is simpler than this is, but this can be done a lot the same. I used to just tell you can't do it when you have plus there, but you can. You just have to know about complex numbers, which you learned for the last couple days. So I know the answer to this like that. Can anybody take a guess at it? Yes. Yes. Got it. It's still x plus 3 and x minus 3. It's just we have to throw an I in there. Why do we have to throw an I in there? Because these are imaginary roots. If you graphed this thing, wouldn't this be a parabola that's shifted up 9 spots? It's not going to touch the x-axis. We know those are imaginaries. Okay, so it's got that imaginary component. Well, if I wanted to like prove him right or wrong, I could multiply this out. First, outside, inside, last. First, x squared. Outside, -3i. Inside, +3i, and they cancel. And the last would be 3i times -3i, which makes -9i squared. And what's I squared equal to? -1. So you take -1 times the 9, makes x squared plus 9. It actually works. Okay? See if you really understood that. I'm going to add a page here and see if you can handle this one. X squared plus 144. Just factor it. There you go. Excellent.